Both point two is going to continue
We should jump the test.
with what we're going to see. Special angles. Now, you should remember there were two special right triangles that you learned back
30,
in.
60,
So 30. So you had a 30, 60, 90. And the other one was 45, 45, 90.
Wasn't it one of them like
Or that's assuming it could be 60, 60, 60.
No, not isosceles. Well, this one is isosceles because the two base angles are congruent. Okay, now a 30-degree angle. So remember from yesterday, if we were going to change 30 degrees into radians, you multiply by pi over 180. So what would this be? Well, what's 30? How many times does 30 go into 180? 30 pi over 180, so pi over 6. Okay. We are going to explore what we call the unit circle. Okay, unit circle means that the radius is equal to 1. So like if I look at from here to here, that's 1. Here to here, that's 1. So anywhere I have a radius, it's 1. Okay? Okay. Now, if 30 degrees is pi over 6 is right here. So I'm going to label that because this makes a 30-degree angle. So this would be pi over 6 radians on the circle. Remember we talked about those are equivalent. It's just a different way to measure, like inches and centimeters. This
How do you know that's pi over 6?
Because we converted. Yeah, we converted 30 degrees into pi over 6.
So that.
Okay, so when we're looking at 30 degrees, we're looking at 30 degrees between the angle and the x-axis. So what we want to do is we want to find the next 30-degree angle. And so basically if we count, the ones that do not reduce are equivalent to pi over 6. Let me explain. So this is 1 pi over 6. 2 pi over 6 would be here, but 2 over 6, does that reduce?
Yes.
Yeah, so we're not going to, so the next one would be 3 pi over 6. Does that reduce?
Yeah.
Okay. 4 pi over 6, does that reduce? 5 pi over 6,
No.
that doesn't. That's going to be our next angle right there. So right here, this is 5 pi over 6 because we say that is a 30-degree reference angle. So this little angle in here is 30 degrees. Okay, so next one, 6 pi over 6. What's that? Is there a question?
Did you say that is 30 degree? Why can't you just automatically know the other? That's what.
How do I know this side?
Yeah, why can't you? And also the one.
If you know those two,
below it.
if you know those
Also
two,
30.
if you know the two that
Well,
we have
30.
now,
Okay, this
then
is
you know
a 30.
because of
We call this a 30-degree reference angle,
vertical lines.
but the actual angle is 5 pi over 6. This is equivalent to 150 degrees, right? Isn't 30 degrees before 180?
But I think what you're saying is if we have both of those angles,
Mhm.
then don't we have the vertical lines postulate? Is it postulate?
Vertical angles theorem, but
Vertical angles. That's
yeah, but technically it's this one and this one are
Yeah,
congruent.
also that one and that one.
Okay,
But if we have those two,
what
then,
is
you know,
this angle down here going to be?
It's gonna be 30. Vertical.
Okay, but what's the angle in radians?
Oh.
It's 7 pi over 6.
So that can't be factored. Oh, it can
Because we're looking, only the pi over 6s are going to, right? This is 1 pi over 6. All the other ones reduce, right? All of these fractions reduce until you get over here to 5 pi over 6. 6 pi over 6, that's the same thing as pi. And then 7 pi over 6 is going to be the next one. All the way over here, what's the next blank pi over 6? 11 pi over 6 is the next one. Yeah, Shana. Yeah. Okay. So here's basically what I'm going to tell you. Anytime I give you, if I gave you 23
wait, I have a question.
pi over 6.
You always start with pi over 6 on that one?
Like, wow.
Yeah, this is 1 pi, because pi over 6 is the same thing as 30 degrees.
Okay, but why can't you do the 30 degree on the other side?
Okay, but this isn't 30 degrees. This is 150 degrees. 150 degrees is the same thing.
So why does it say 30? That's just the angle?
That's what we call a reference angle. So the actual acute angle inside of here is 30 degrees.
Okay, so why can't you start with the pi 6 on the other side of the acute?
Because remember we talked about standard position
Oh, you wanna
yesterday?
start on the right- oh, okay.
Remember, we're always starting, this is our initial side. So if I want to draw a 5 pi over 6, I'm going to go all the way over here. So pi over 6 is just this short measure, but 5 pi over 6 goes here.
And then just add all
7
that.
pi over 6 goes here. 11 pi over 6 goes here. So what I'm basically telling you, anytime you have something that's not reducible and it's got a pi over 6, it's going to make a 30-degree angle with the x-axis.
So if you multiply 11 pi over 6 times 180 over pi, you'll get whatever degree that is?
Yeah.
Yeah?
Okay. All right, next. Let's actually, we can do pi over 4. Okay, so now let's do pi over 4. So 1 pi over 4, if I want to translate that into radians,
45.
it ends up being a 45-degree angle. Now 45 are a little bit easier because they're right in the middle. So 1 pi over 4, or just pi over 4, is here. Pi over 4, again, is the same thing as 45 degrees. Okay, it's just a different way to say it. So if I said, show me an angle of pi over 4,
Just 45
it's just 45 degrees. Okay, next one, 2 pi over 4, well that reduces. So the next one over is 3 pi over 4.
But is it always going to have like those boxes right there?
No, we just did this on purpose for your notes, so you could see.
Wait, I have a question. The pi to the 4, like pi over 4, the first one,
Yeah.
to the middle line, right
Here?
there, that is also 45.
Yeah, this is, bless you. This is 45 degrees, this is 45 degrees, this is 45 degrees, this is 45 degrees.
Why don't we do it for that one there?
Well, this is going to be a pi over 2 up top
That's
here.
2 pi over 4.
Right, but that reduces.
Oh.
Okay, so I'm specifically looking at the ones that do not reduce. Okay, so tell me, what's the next one going to be? 5 pi over 4 goes here. I also want you to consider,
But, are we always going to have like all, like, are we even going to have this list?
okay,
In general?
we're not going to have the list. Here's what I'm trying to do. I'm trying to show you patterns within the unit circle, and I'm looking at one type of angle at a time. So first, we looked at all the pi over 6 or 30-degree angles.
So yeah.
Now we're doing all the 45. Next, we'll do 60, and then we'll do 90s. 90 is the easiest one. Okay, what's the last one over here?
7 pi over 4.
Yes. Now you can also think of this in like terms of mixed numbers. What's 5 over 4 as a mixed number? 1 and a fourth. So where's pi? Pi is right here, right? Halfway around. So 1 and a fourth pi is the same thing as 5/4 pi. Okay. Let's continue to explore. Pi over 3 is going to be how many degrees?
Is 60 called like a quadrantal angle?
Yes, the 90 ones are quadrantal angles. Did you look ahead?
Yes.
No.
Or you remember it?
Okay.
All right, pi over 3. So now do you see these are 60-degree angles inside here? So 1 pi over 3, or just pi over 3, is going to be here. And then 2 pi over 3 goes next one over. 4 pi over 3. And 5 pi over 3. Now, if I said 7 pi over 3, that's still a 60-degree angle, but you're going to end up going around the circle more than one time. Right? 5 pi over 3. Next quadrantal angles. So these are the ones that are on the X or the Y axis. So let's start with the first one. This would be, so imagine the initial side. This would be right here. How many degrees? It would be 0 degrees or 0 radians. 0 degrees and 0 radians are the same thing. It's that positive x-axis. What happens when you get up here? How many degrees is that? 90. What's 90 degrees in radians? Okay, let's think about this. All the way around the circle was how much?
2 pi.
So
2 pi.
1/2.
So 0 radians is also the same as 2 pi. Remember, the radius is 1, so 2 pi r. So what would half the way be?
1 pi.
Just
Pi.
1 pi, right? This right here would be pi. What is that in degrees?
180.
180. So now tell me,
Half pi.
how much is this? This is half a pi,
Yeah, half a pi.
right? Pi over 2. Okay, now at the bottom, how many degrees and how many radians? Well, this is 180. What's 180?
270.
So 270 degrees. And it would be 1.5 pi or 3 pi over 2. So what do we notice? Well, anything that is just a pi or a 2 pi, where do you think 3 pi would end up? If this is 2 pi, 3 pi would be here, 4 pi, right? 5 pi, 6 pi, and we could continue to count.
Wait, what's 270 degrees?
3 pi over 2. This is pi over 2. This is 3 pi over 2. Where do you think 5 pi over 2 would go? Up here. And then 7 pi over 2, right?
Because we're counting by 2.
Because anything over 2 that doesn't reduce is going to be on this axis. So anything, so multiples of pi, okay, so are 0 or 180. Multiples of pi over 2 are 90 or 270.
I just don't get how is that 0 degrees and that's 180.
Okay, so
I thought a line in general.
okay, think about it this way. You have to remember how we were drawing. How much is it all the way around the circle? 360.
So if you start from there at 0.
So if I start from here at 0,
Oh, and then
90, 180, right? 270, 360. I could keep going. 450, right? We talked about that. You can go around the circle more than one time. Okay?
Can you start from a different point?
What's that?
Can you start from a different point or it has to be on that side?
You have to start on the side. This is our initial side. Yeah. Okay, let's see if we could do this without looking back at what we had. This one is 0 radians or 2 pi. So I don't want you to put, let's try not to put the degrees. Let's try to just do the radians.
Wait, so is this 30 or it's just like all?
Okay, this is all of them. This is a 30-degree angle, this is a 45, this is a 60. Okay, so this is a 30-degree, then up to here is 45, and then up to here is 60. Okay, so our 30 degrees were all blank pi over 6. So this one has to be pi over 6. Do you remember what's the next one over that doesn't reduce?
4.
No,
4 pi over 6 reduces.
No, I thought.
5 pi over
5
6.
pi over 6.
7.
7 pi over 6 is the next one that doesn't reduce. And 11 pi over 6.
So can't you just add 4 on?
Yes, you can. For these.
That we do
Let's
pi
look at, okay, the next one, what was the 45 degree? Those were all the ones that were over 4. So pi over 4 over here. 3 pi over 4. Next one.
5
pi over 4.
And then 7 pi over 4.
And then 7 pi over 4. So I'm trying to get you to see like the patterns with the numbers. Also think anything that's a 45 degree, right? A 45 degree will always be something pi over 4. A 30 degree will always be something pi over 6. And a 60 will always be something pi over 3. So think 45, 4, 4. And then the 3 and the pi over 6 and the 60 and the pi over 3s are like swapped. So this one up top here is
Pi over 3.
Pi over 3.
pi over 3.
2 pi over 3.
2 pi over 3. Sorry, my pen stopped working. Give me a sec. So yeah, pi over 3, 2 pi over 3, 4 pi over 3,
5.
5 pi over 3. Okay, now let's try to do the quadrantal angles. Let's see if I can get this to work. There we go.
Yeah.
Okay, last one's on here. Okay, this one's already 0. This one at the top
Pi
is
over 2.
pi over 2.
Pi.
Pi.
3 pi over 2.
3 pi over 2.
That's it, right?
Right, and I already listed this one as 2 pi. And then I can
Wait,
keep,
that one's 2 pi?
that one's 2 pi, because all the way around. Okay, take a look. Okay, so we've just listed all the special angles that we need to know for a unit circle. Okay, and these are special locations. Good? Okay, moving along. Why do we need to know those special angles? All right, like why? Why are all those angles special? Because they have special values when it comes to trig functions. Okay, so let's start with, we're gonna say theta. Theta can be any of these angle measures, okay? So theta could be pi over 4, right? So what we wanna do is we wanna evaluate, and we're gonna use Pythagorean theorem, which I'll, and we're gonna use these values. Sine, okay, so we're gonna have sine is y over r. Cosine is x over r, tangent is y over x, okay? And then we have all the reciprocals, right? They're just swapped. Good? This here is gonna look more like what we did in the first lesson. What I want you to do is I want you to draw a little x and y axis, and I want you to plot the point -3, 4. My pen keeps disconnecting.
Oh boy, good.
Don't know what's going on. Where's -3, 4? What quadrant?
Second.
In the third quadrant.
So
Oh, no way.
Second quadrant?
Yeah.
-1, 2, 3, 1, 2, 3, 4. Okay. Now take that ordered pair, -3, 4, and let's connect it to here and make a right triangle. Now I want to figure out what r is. Remember I said it's going to be Pythagorean theorem, so I'm going to have -3 squared plus 4 squared equals r squared, right? Technically we don't have to draw it, but I wanted you to kind of visualize, because remember, we also can look at opposite over hypotenuse for sine. This is just a different way to define it. What do we get for r?
5.
We get 5. So now we want to find sine of theta. Well, how did we define it? What's the y coordinate?
4.
4 over
5.
5. Right, this was x, this was y, and we figured out r is 5. Okay, if sine is 4 over 5, we can find cosecant. What's cosecant?
5/4.
5/4. Good. Cosine. So this is x over r. Our x coordinate is -3, so it'll be -3 over 5. And now the secant is -5/3. Okay, and last we have tangent and cotangent. So again, this kind of goes back, it kind of combines this new information, what we did in the last lesson. What's tangent? That was tangent?
-4/3.
Yeah, so it's going to be y over x, so -4/3. And then cotangent is
-3/4.
-3/4. Are you okay with that? So that's just using this alternate definition. Of course, could you use the triangle? What's this? This is -3 and this is 4. And could you do opposite over hypotenuse?
Yes.
It's the same idea. It's just defined in a different way according to what r
When
is.
we do sine and stuff like that,
Yeah.
our angle we're looking at is that 45-degree angle, right?
It's not necessarily 45. It's going to be a little bit bigger than 45, but yes, it's like, but it's really,
No, we're looking at, so you know how when we use like SOHCAHTOA,
yeah.
we would have let's say like 30. We have the angle and the degree.
Yeah.
And we have the hypotenuse. We use the 30 as the sine, right?
If that was a 30, yeah.
So what are we using as a reference of sine?
So we don't know what the angle is, and it doesn't matter what the angle is. All I want you to
How do you know
do,
what the adjacent and the other angle is? The
well,
adjacent-
okay, what's this length here?
That's the -3.
Yeah, this is negative, oops.
That's all.
So this is -3, and this is 4, and this would be like our theta, right?
How do we know that's theta?
Well, the theta is the angle that goes from here to here. So we use a right triangle. Theta, okay, remember how I was just labeling previously? Theta, or whatever angle, is always the angle that it makes with the x-axis.
Always.
Always, yeah.
Like, it's not, it
Right?
can't be the right,
You see how I label these? It's always the one that goes to this axis.
okay, so it can't be that 45-degree angle,
No, it's not a 45 in this case.
or that 90-degree.
Here, let me, maybe what I'm gonna do next, we'll clarify that. Okay?
I'm just confused because I didn't know which one we're looking at to find the opposite and the adjacent.
Well, I didn't, I used this information, but you can also reference the triangle. Right? So if
So
I'm,
you'll give us like that information.
I'll give you, well, this you need to know.
Wow.
Yeah.
That's not the same as opposite, right?
It is. Look, if I did opposite over hypotenuse, don't I still get 4/5? Yeah. It's just a different way to define it.
I don't remember.
Okay, let's keep going. Let's see how far we can get. This is what I was talking about, Gabe, about the reference angles. The reference angle is the acute angle formed by the terminal side and the x-axis. So let me just explain here. All reference angles must be between 0 and 90 or 0 and pi/2. Okay. In quadrant 1, it's easy. Our angle is just whatever this is. Okay, so our reference angle is going to be equal to theta. Okay, now what if our angle is in the second quadrant? What would be an example of an angle in the second quadrant? 120. So let's say this angle is 120. How would I figure out the reference angle? The angle that's here.
Would be 60.
Okay, how did you get that?
180 minus 120.
Okay, so we did 180 minus theta. Okay, you just kind of did that in your head. You really didn't put that much thought into it, because what if I told you it was 150? What would your reference angle be? 30. Or if I gave you it was 110, you know, it would be 70. It's how much is between here and 180 degrees? What if it was in radians? What's equivalent to radians? 180 degrees was the same as pi. So if you had it in radians, it will be pi minus theta. I know it's harder to think in terms of radians, so that's why I have you kind of visualize it with degrees. Okay, now what happens if I have an angle in the third quadrant? Let's say 200 degrees. Or give me another.
270 minus theta.
230? Fine. Let's say this is 230 degrees all the way around here. How do I find the reference angle?
230 minus 180.
You have to do 270.
So I do the angle minus 180 this time. Right? So if this was 230, this angle would be how much?
Oh,
50.
50. That would be 50 degrees. Good. Okay. What if it was in radians? We would do pi minus, or theta minus pi.
4/3 over 3. 4 pi over 3.
Okay, now quadrant 4. So give me an angle that would be in quadrant 4. Like 300.
320.
Okay, how do I find the reference angle now?
300 minus 180.
How much is it all the way around?
360 minus
360. So if this is 300,
360 minus 300.
360 minus the angle. Or in radians, it would be 2 pi minus theta. I know, a lot of information in this section. Okay, this part
Wait,
is...
but 360 minus theta would be 300.
No, if I did 360 minus 300, that would give me 60 degrees left over.
But you wrote minus theta, which is
Yeah, so here, if I did 360 minus 300, that would give me 60 degrees.
yeah,
This angle right here is 60 degrees.
yeah. Yeah, I get that. But just the equation doesn't make sense. It's just like 360 minus theta, which is we're trying to find theta.
Okay, but so picture all the way around is 360, and I've gone this much. How much do I have left over?
Yeah, 60. I get that.
So what if I said it was 320 degrees? What would my reference angle? 40. Because you did 360 minus 320. I know. It's, again, it's a lot to process because there's a lot of information. We're trying to put it all together. Now, this is actually a review. Sketching an angle and finding a reference angle in degrees. Oh,
It's already in degrees.
that's already in degrees. That's supposed to be in radians. Little typo, radians. Okay, 330 degrees, so let's sketch it. So I'll make an axis, and I'm gonna trace over my x-axis for my initial side. Where will 330 degrees go? Oh, you know what? Actually, this was fine. There was no typo. Sorry. It is in degrees. Sorry.
But you don't even need to draw it though. It's just 30.
Right. So there's my angle of 330. So my reference angle.
The theta's 30. But you don't even need to draw it.
Well, I want you to sketch the angle. So there's two parts. Sorry, sketch the angle and then give the reference angle in degrees. So, yeah, you guys probably just did this in your head, but what's the actual process? 360 minus?
Minus 330.
Yeah, so, the pen stopped working. Okay, so you'll just write reference angle equals 30. Negative 800 degrees. So what do I need to do in order to...
Add 720.
Okay, is 720 still gonna be enough?
It'll be a negative, but
Okay, we could. So, here.
I still check.
Oh, no.
I tried doing it in my head, but I don't think I got the right answer.
Well, it's adding another multiple of 180 or 360. I mean,
Oh, I
Yeah, I know it.
add 360
I did it.
plus 360 plus another 360.
Is it 280?
I missed the. Okay. I missed the first step. Okay.
Anybody?
Oh, so you want
It's in the
three
third
360s?
quadrant. It's in the third quadrant.
But can we just do two
Oh my
360s?
To make it what?
But it doesn't matter if it's negative.
It doesn't matter as long as you knew where to go. So if you went and stopped with 2, it would be what? Negative 80 degrees. Okay, so let's go ahead and sketch it.
3.
How many times? So I need to go backwards.
So.
How many
On
times?
the fourth quadrant, like right there, like right on the.
So it's going to be like right here.
Yeah.
And it goes around 3 times.
Okay, so.
So we're going to go backwards, right? So now we're going to go clockwise. It's going to go around.